Okay, our next talk, very interesting project, the Frank Lloyd Wright concrete block house, the Khalil House. And this will be done, presented by two speakers, Chris Dabek and Tara Ikenouye. And Chris is the vice president of Stone and Lime. Chris established the quality control measures and develops creative solutions to unique preservation challenges, and has done work all over the U.S. and North America. He is the past president and currently on the board of directors of the Association for Preservation Technology Northeast Chapter. And Tara is an architect and senior associate with WJ Boston. Her work focuses on solving building enclosure problems related to distressed materials and assemblies, water infiltration, and historic preservation. Tara manages projects from investigation through construction for both new and existing buildings throughout New England. Chris and Tara?
Hi, everyone. Good morning. Chris and I are pretty excited to talk about this project that we worked together on. I guess it was about 5 years ago now, 2018. No. All right. Okay. We'll take it from here. So the Khalil House is a Frank Lloyd Wright designed house, Usonian Automatic. It's located in Manchester, New Hampshire. It was built in 1955 for Dr. Tufik and Mildred Khalil. They were, Dr. Tufik was a radiologist in New Hampshire, and he was friends with the Zimmermans, who lived up the road a couple houses down, and they also had a Frank Lloyd Wright house, a Usonian house. That house, red brick masonry, lovely warm wood. They said, "This is great, can we get one?" And then this is what Wright designed for them, which is a Usonian Automatic. It's also lovely, too, in its own way. Constructed of the modular concrete block. It's exquisitely maintained. These were pictures of the first time that we came to visit. The Khalils took a lot of care of their house, and they lived in it from the time that it was built until their death, and then it passed to Dr. Khalil's brother John, who lived in the house until 2018, when he passed away at the age of 101. So at that point, the house passed to family members, and we became involved, WJ became involved with the family at that point, because they were trying to figure out what's the future of the house going to be. They knew that they needed a new roof. They wanted to get an assessment of the whole house in general, and so they asked us to assist them with that. So our organization is generally, our presentation is generally organized in kind of two parts. I'm going to give you a little history of the house, Usonians in general, the work that we did around the condition assessment, and then we're going to get into reconstruction of a site wall at the that was damaged, unfortunately, during the project. Not related to our work, though. So Usonian Automatics. Wright designed Usonian Automatics from about 1930 to 1950. He called them Usonian for the United States of America and Automatic because he thought that the homeowner should be able to construct these houses themselves from local material and labor. His target market were, middle-class Americans, modest income. He was hoping, the houses wouldn't be priced too high. You can see in the ad on the left, this was a record from the Khalils, and it didn't have a date, but, it's sort of contemporary of the 50s, and it looks like this house in Arizona is going to cost you about $25,000. I don't know if that includes the labor that you're going to put in on your own or not. So Khalil House, this is the plan, the original plan. It's L-shaped, and you can see the carport to the north. It's mostly one story. There's a two-story height in the center. We call it the tower. You enter the house through the carport, into the study, into the living room, where there's a bay of light coming through the windows, which is really lovely. And then the wing off to the side has the two bedrooms in it, master bedroom and a guest room. And there's actually a guest house that's not shown on this plan. It's kind of about here. Same construction. It was never finished. They mostly used it as a shed. So for the Usonian Automatic construction, we're talking about concrete coffered blocks. These photos, and many of these photos you'll see in here, were from the Khalil family. Dr. Khalil and Mildred kept amazing records. They have photographs, they have original receipts, invoices, correspondence with Wright. It was just this great treasure trove of documents that the family gave us access to. So These are photos from construction. You can see the blocks, generally 12 by 24 by 3.5 inch module, steel forms, cast on site, although Chris found an invoice for some blocks that were made off site. Dry tamped. These blocks have they have a half circle channel around them so that when the two blocks come together it forms a 2-inch diameter perimeter channel through which the steel is placed and then the grout is pumped in. So you can see some of the steel being placed there and the blocks going up. These are some of the units that were extras. They were in the backyard the first time we came to visit, and these are some of the more. This is not your typical form, I guess. These are like corner units here, so there were some specialty units there. But on the left, you can see that half circle channel there. So one of the things that we heard from the family, and I think Chris probably can speak to too, is the challenge of this type of construction is that these blocks, in order for the channel to be formed, they have to be in contact. So you don't get the benefit and the cushion of a mortar joint in case something's a little bit off. So they really had to fit well together, and Dr. Khalil reported that during construction, the masons at the time had challenges with any kind of variation in the perimeter of the block. And so on the left, you can see they've got a couple courses going up, and on the right, I don't know if you guys can see it, but that's a mason working at a grinder, presumably grinding off some of the edges of the block so that they fit together there. This is a photo of construction of the carport. So that's Mrs. Khalil standing on the carport there. You can see they erected scaffolding to support the units until a concrete topping slab could be poured on top there, and you can see the steel reinforcement before the concrete was poured. So one of the issues that we were going to help the family with was around roofing and leaks. The house had a long history of leaks, starting from almost like immediately after it was constructed. There's a lot of correspondence between the Khalils and Wright and the contractor about roof leaks, and one of the issues that we saw right away were low flashing heights. So I think Wright kind of has a reputation around some leaks, and I can kind of see why. So on the left, that's Dr. Khalil right there, and he's standing next to the tower as it's being constructed, and the orange arrow kind of points you to the same location. This is southern New Hampshire, so we get a lot of snow, and anything that builds up there, because there's not a lot of room between the windows, either the operable ones or the fixed, there's just water that was coming in there. So one of the first things we did was help the family with a roofing replacement design, and everyone decided that the biggest threat to the house was water intrusion. The house was already not well insulated because there's only one width of units, so it's kind of blowing heat out everywhere. So we decided to not add insulation to the roof. Without adding that extra layer, we tried to get as much flashing height as we could. And the other thing that we decided to do was once they started demoing the roof, there were remnants of what we thought was the first roof, which was a reinforced resin that was either pigmented red or painted red. And the red color, you can see it up on the right there, was the same as the back patio concrete, and then inside the hearth was actually this really lovely red color. So we went back with a modified bitumen roofing system. So the cap sheet had red granules, and we used PMMA flashings directly to the concrete, which was kind of it was a choice. This house is privately owned. It's not listed on the National Register at this time, and that's not totally reversible. With historic structures, you kind of want to do things that are reversible, but that was what we felt was best to do in order to protect the house from any water that might get in at that joint there. So once the roofing was completed, we decided to tackle some of the water staining at the inside of the house, and this is at the tower. And this work was really done by the family. That's the Khalils. They erected some scaffolding in the kitchen and spent the winter scrubbing the concrete. We advised on some means and methods, and it was really hot water, steam, vinegar, and a brush, and some teenagers. So that's what it looked like to begin with. This is what it looked like right after, and then this is last spring. And the staining hasn't come back, thankfully, because we stopped the roof leaks, but you still are getting some water staining, mostly associated with the windows. So, unfortunately, while we were working with the family, an incident happened at the site wall in the backyard. We never fully got the whole story, but you can kind of tell from the tracks and the mud splatter on the wall that somebody maybe hit the gas instead of the brake, or reverse instead of forward. So over 70% of the site wall was damaged. There was very little of the historic material that could be salvaged, so everybody decided the best thing to do is just reconstruct the whole wall. And with that in mind, we decided to try and match the new units to the house in terms of, the color of the concrete, the texture, and things like that. So after this, I like to joke it was a happy accident, because we had the opportunity to look at some of these fragmented units and, peek inside. So here you can see the perimeter channel, the steel that's running through it. We found that there was some voids, so there must have been some issues with pumping the grout into those channels. We did some carbonation testing, and the concrete of the units was carbonated, but the grout was not. So it seemed like the grout was still providing some corrosion protection to the steel, which is consistent with the house, because we didn't really find a lot of distress at the house. And you'd think if there was a lot of corrosion happening to the steel, it would be all over the place, but it was really just a handful of cracks here and there. So in addition to our field investigation, we took some samples from the backyard unit, the damaged block, and a spall from the house to try and understand what the mix design was, and we could use that for the new blocks. And then here's just some photos from that petrographic analysis. And on the right, this was the spall from the house, and I think it had like 5 coatings, multiple coatings on it, which was consistent with stories about Brother John, who apparently liked to experiment with different coatings and things on the house, either for aesthetic or performance issues and things like that. And then on the left, that's a section through one of the damaged units. You can see the grout channel. There was a large chunk of mortar that wasn't mixed very well, and then a bit of a bond line separation between the concrete and the grout. So from this, they determined that the concrete had a siliceous sand mixed with quartz, feldspar, granite, and mica flex. And the mica was actually probably one of the more challenging aspects of the mix, because the house has this like really lovely, beautiful kind of sparkly effect to it. And so at this point, this is when Chris and his expert team came in and kind of brought the project home. And I'm going to hand it over to him so we can talk about the construction of the units and the sidewall reconstruction.
Thank you. Good morning, everyone. So we've been fortunate enough to work on about 4 or 5 of these Frank Lloyd Wright projects, and there's a few constants. One is they're extremely time-consuming. The owners are typically very, very high maintenance. And 3, we never make any money. So when Liz Janney and Steve Khalil called and said, would you like to be part of our team, we obviously jumped at the opportunity. There was a tremendous amount of information the family had, which was extremely helpful in some cases, but kind of led us down the wrong path in others. There's almost too much information. We were able to find invoices for blocks, for forms. We were able to track down the original sand pit for the blocks. We found the Duracrete Block Company, which was located just north of Manchester, New Hampshire. And we found that sand that had the perfect fleck. When you walk in through the building, when the sun shines on the walls, I mean, it's just beautiful. And so, being kind of a preservation contractor, we always try and find the original materials, right? Try and recreate using historic. So we found the sand pit right down the street. It was perfect. Unfortunately, we did some of the testing, and it was susceptible to ASR. So we couldn't use it. So we ended up finding a location in Western Mass in order to build these blocks. So I think the longest kind of process here through the overall, I think I heard in the first presentation, was kind of the mock-ups. The mock-ups take a very long time. I think the mock-up process took longer than the actual casting and the installation all combined, right? So there was some attic stock there. You saw kind of piles and piles of blocks out in the back corner. Nothing was sorted. Different levels of deterioration. It was hard to tell what was original, what wasn't original. We were able to salvage a few blocks from that kind of attic stock, really spent weeks kind of repairing those historic blocks to be able to create a block that then we could, mold and then create replication units. So you can see here, just simple silicone molds. I think we ended up having, I think it was about 70 or 80 blocks that we needed to recreate here, different shapes. Here's some images of the mock-up process. Again, one of the challenges is, what are we trying to match? Where there's different layers of coatings, different levels of coatings, and different elevations. So there was a lot of discussion relating to that. And then the amount of exposed aggregate you can see here. We played around with that a little bit. At the end of the day, we ended up installing a coating on one section of it, which is controversial, I know. But that was the owner's wish. Reconstruction details, Tara mentioned. Every single block, kind of that first course, needed to be absolutely perfect, right? There's no mortar joints. They were about a 1/16 of an inch, kind of all tied in together. So if you don't get that first course perfect, everything else is going to be out of line. So it was a very slow process, kind of tying this all together, grouting as we went up the wall. Here's a little bit of the process. Very slow, very slow. The demolition process, I have to say, took 2 to 3 times longer than we anticipated, and the reconstruction, same thing. Just very, very slow, tedious. And here are kind of the final photos here. I want to say one thing that was really interesting when we were looking through the original documentation here. The original budget, the Khalil family was told, was between $30,000 to $40,000. This is back in 1955. It ended up costing double that. It was somewhere between $70,000 and $80,000. So, challenging construction. I mean, for us to rebuild this little section of the wall was challenging. We had masons that had 20 plus years of experience that really struggled with this. So, frankly, I can't imagine a regular homeowner, building this whole structure, frankly. But happy to say we came in under budget, on schedule. We started the project in March of 19, and we were completed by September